factorization. In fact, it will be going into the non-integer dimension. So you can do that. So, and then adopt the U gate is seem to be okay. You could get everything. In fact, it's implied the non-integer. What is the integer is divergent. So you could think of the standard here. The standard here. So there is a lot of that. And also you should add the fermion in the middle. So if you could get everything together. So for the standard model, Higgs. This is for the string 2. I didn't write down the result. This is also for a Pauchy family. Pauchy family. So you should remember the theory contains not only Higgs, also the fermion and the others. So you could add together. I was thinking about quartic divergence, because if a quartic divergence, you have two, it's become very bad. It would be this would be quadratic, this would be quartic, this would be 6 power and so on. So it's better than this thing would be would be cancelled out. So in a complete theory, you can imagine in our wall, the so-called 4-dimensional Minkowski space-time with those force field gauge group. If you could think of that, then you should realize that this particular our wall should be by itself should be complete. So all the bad thing would be cancelled out. Maybe it's my own this could be my own thinking. But if you think that the quark and the lepton and all of that seem to be forming a good good wall by itself. Maybe I so I think that maybe it should be like this. In other words, we live in the SU color 3 times SU2 left, the 2, and the time U1 and time SU's flavor or family 3. So we live in this type of Minkowski space-time. It supports the lepton wall, and it also supports the quark wall. It's the force field or gauge field Minkowski space-time. So my search could be ended like this. I finally arrived at a standard model that had the SU3 family to protect the so-called lepton wall. The SU3 color to protect the quark wall. This explains the origin of Mars. It has neutrino oscillation in a very natural way. This is the SU, this group standard model in a 4-dimensional Minkowski space-time. Is renormalizable. All these are point-like Dirac particle. Point-like Dirac, not a point. Is the physicist point is different from the mathematician point, because physicists, here we have the so-called quantum principle. So all these are point-like Dirac particles. Point-like, I should say point-like. Beyond that, there is nothing. I hope everything will be happy in this war.
Any questions for Professor Hwang? Yes.
Where the force come from? 力量从哪里来 ？Force come from 力量从哪里来？
我在这let me use Chinese. He said how the force come from. In my thinking, at this point, I think the force is already there. In fact, I assume that everything have a characteristic under SU3, SU2, U1, and other SU3. But this already label the force field. So in this language, I think that if you try to come to think about it, you realize that everything should have the number and those screw, SU3 color and SU2 black and U1 and SU3 family. If everything in your wall, everything in your wall have a explicit all the number under this group. So the force field in my thinking, maybe you could have a better thinking. In my thinking, I think that is the very good summary of the so-called the standard model. We try to maybe we don't have the what I should say. Usually we don't think about this question. When we say the standard model, you don't realize that the standard model has the other thing. And the other thing you have to specify. So the force field, I think, is the one with your space.
Any other questions?
In the SU3 color group, we got asymptotic freedom. But I guess in this family SU3, you shouldn't have it, right? Otherwise, phenomenology will be wrong. I mean, for the SU3 family group, you should not have asymptotic freedom.
No, what is it should have that.
You should have it?
Yeah, because of gauge field. That's why my 1985 paper is the so-called useless paper. The overlay, I show that if you add a few Higgs field, this doesn't change asymptotic freedom.
Yeah, but I'm talking about the SU3 group, SU3 family group. If you have asymptotic freedom, then might mean you got additional confinement in the infrared, which is.
I don't know whether confinement is there or not.
Okay.
But if you go to the Q square high enough, the asymptotic freedom is there. And if you have the Q square go to very large, the asymptotic freedom there, the Landau ghost disappear. Of course, Landau ghost is you have to go to very high. But from the gas point of view, everything should be very consistent. That's why I think this our standard model is real standard model. It doesn't change anything. It changed something. The LHC is basically is wrong because the remaining hit, the remaining hit only touch lepton wall. So the LHC doesn't allow you to search for some of this thing.
Any other questions? If not, Thank you.
好，谢谢。好，谢谢你啊。
谢谢。你要站起来吗？
好，
你要站起来。
啊，没有问题，我把这个关掉。
叫我给4
没问题。
没问题吗？
对。
请问今天有签名吗？
没有
Is everything recorded?
Yes, recorded.